Hey friends, I'm Scott Hanselman. Thanks for hanging out with me today. I wanted to do another episode of computer stuff they didn't teach you in school. I wanted to talk about IoT, the Internet of Things, but I don't know a whole lot about IoT, so I decided to bring Microsoft engineer Tara Walker, who is an IoT expert, on the show. Hello.
Hi, Scott.
Thanks for hanging out. So you have been an engineer for many years. We won't say how long, but
I was
it's
about to say,
been
don't tell on me. Come on, man. I want to be young
some
and
years.
vibrant too.
Okay. So some years, that is, some amount of time, and, but you've been doing IoT for a long time. You did mobile devices, you did all kinds of stuff, but the last several years, last many years have been specifically Internet of Things devices. Is that right?
Yeah, that's my thing. I love taking little things, making it move, making things sense. Yeah, I love IT. I'm in my element now. I'm in my zone.
Really? Okay, so that means robots and sensors and all that kind of
All of
stuff,
that.
and
Yes. Yeah.
okay, cool. So I've got a bunch of stuff on my desk, you have a bunch of stuff on your desk, but I wanna get a level set about what an IoT device is. So I got a couple of quick examples. So
Okay.
I made this Tony Stark heart. It's 3D printed. I got it from a kit.
Ah,
It's super
nice.
cool, right? And
Yeah.
it turns on and off. Is this an IoT device?
Okay. Well, I'm not sure. Does it do something more than turn on and off?
No. So it turns on and off. It does plug into USB, but only to get power.
Does it have like any kind of, does it blink on demand? Can you do other things with it, or
Mm,
does it sense someone's coming closer,
nope.
or
So it is dumb. I guess it has power and it has a light. It has a
yeah.
there's some wires and you can see that there's some copper in there, but it's pretty dumb.
Yeah, no, no, that wouldn't be an Internet of Things device. You kind of need a brain to it, and that one doesn't have a brain.
Okay. So stuff that lights up, even though it looks high tech, not necessarily an Internet of Things. You gotta
Yeah,
do
nah.
something.
Need a brain there. Yeah, but it's cool though. Super
It is
cool.
cool. It is
It
cool.
is. I mean, I want a Tony Stark 3D printed
Mm.
heart
Yeah,
thing.
maybe after this, I'll send it to you. We can upgrade it and we can figure out
That's
something cool
right.
to
We
do
can
with it.
make it do stuff cool, like like the movie. I like that.
Exactly.
Okay, let's
Plug it
do it.
into the AI. Okay. So when I think about IoT, I want to do like a hello world because I've been talking about computer stuff that they didn't teach you. Hello world's where you start. What's the hello world for Internet of Things?
Oh, that's easy. You're gonna blink a LED. So just a little light and making the light blink. There you go.
Okay.
That's hello world
So
just starting.
I get some of these,
Yep.
some LEDs. I get a little board to put them on, and basically, I could. This could be a hello world actually because it's like if I plugged
Oh,
it into something smart and made it turn on, that could be a
absolutely.
hello world.
That could be a cool hello world. But yeah, it'll be a hello world.
Okay, cool. Now I hear about Raspberry Pis and I hear about Arduino. What is the difference between those things, microcontrollers and microprocessors? Because it's really confusing if you want to get into IoT as a beginner.
That's a great question. I do you mind? I have a really quick, like, kind of slide about it. Would
Mhm.
that help?
Let's see it.
Okay, let me share my slide.
Did you need to get the door or something?
Yeah, the door rang. Alexa, answer the front door. Okay.
See, this is some IoT right here, actually. Something happened.
Okay, bye. Alexa, stop. I'm sorry. I gotta go answer the door. Give me one
Go
second.
do your thing. Say hi to Mindy for me. Actually, that's an IoT thing. She'll probably make me cut this, but what's interesting about that is having a connected house like that. That's an example of the Internet of Things. So she was able to talk to her Alexa. The Alexa then answered the door. She's got her whole house set up as a smart house. So hopefully, when she gets back, she'll be able to explain to me the differences between microprocessors, microcontrollers, and which ones are involved in making Alexa talk. So it sounds like my device is a dumb device. It doesn't really do anything interesting, but her stuff is a little bit more intelligent. And we'll hear about that in a second.
Hello.
I'm going to keep all this footage for the YouTube
Oh no, you are not.
because
Look.
after you left, I was like, talk about Alexa being Internet of Things and how you have a connected house, and you answered it with your voice. That's cool. That's cool stuff. So you just shared your screen here. What do we got?
All right. So you asked me what was the difference between MPUs and MCUs,
So, okay, so
and
MCU microcontroller, MPU microprocessor.
you know what? You're right. What is with us acronyming people to death in tech? We do that, don't we?
We do.
So yes, MPU is microprocessor, and then MCU that you'll hear a lot, or UC, because some people say UC or UP, will be microcontrollers. So Let's talk about the bigger one, microprocessors. Now, the reason why I said the bigger one is because microprocessors are going to be a situation where I could run a full operating system on it. I bet it might be an embedded one, but things like Linux, right? There's different flavors of Linux. There's bigger, smaller versions of Linux, but I can run Linux on a microprocessor. It's going to run a full operating system. I can run Windows on a microprocessor. It's going to be a smaller device, but it's pretty much a smaller version, a micro version of your normal CPU that you see in your laptops. But it's optimized for these smaller things. So you're going to have external flash, the hard drive, all the data buses, all the things that you're accustomed to in your laptop, but it's just shrunken down and a little bit more limited so you can run it on some of these devices. Now,
Okay. So let me say, so I got this a Raspberry Pi 4 that I bought. It's
mhm,
got like HDMI and it's got a USB. And when I boot it up, it has a desktop. It has like a little mini version of Word. It has browsers. It does more than one thing at a time, right?
correct. Yeah.
Okay.
And you know what? That's a great point. You're spot on. It does multiple things at a time, which most, if you think CPUs do, then your computers, your laptops, multiple things at a time. Um, you actually do our lovely context switching, all of that
Mm,
that happens in a typical operating system, right?
okay.
That is what a microprocessor, they're big enough to actually run a full operating system is.
Mm,
Now, that is completely different with a microcontroller.
okay.
Microcontrollers actually don't run operating systems. Well, here's the trick. They do, but they don't. There's a pretty much what we call a task scheduler, a task switching system called RTOSs. Now, I'm completely
RTOS, real time operating system.
correct.
But
See,
it's not an operating system because
but
you're.
it's not really an operating system because think about what an operating system is. You have a separate scheduler, you have, your kernel and your processes and everything running. That's not really what the RTOS is. It really is running a task. We're going to say it that way. And this task runs in parallel with, okay, I'm running, then I need to switch over to something else. I'm actually going to stop running and run another task. But it happens so quickly that it looks like, keyword being look, as
Mm.
if you're doing like a normal operating system would do, where
Okay,
operating
so it's
system
a
actually
juggler. It's
it is a
juggling,
juggler.
but
That's a
all
great
3 balls look like they're in the air, but they're not.
you know what? That's a really good analogy. Absolutely. So it's really about, hey, I'm running this, then this has to wait for a minute. I'm running this, but it's so quick
Hmm,
that you don't see it. And everything, another thing about an MCU, other than it running an RTOS and talking about the operating system part, is everything is on the chip. So the RAM is on the chip. There's no external thing. The flash, so the storage is on the chip. Any of the subsystems, all of that is on the chip. Um, Anything you can think of that would be a typical file systems, all the things you think of is, hey, I'm going to have this file system. It's a part of my operating system, or like
mhm,
Linux, it's modular. I can pull in different ones. No, on an MCU, you have very, very little space, like truly limited space.
okay.
Some microcontrollers can be as small as 8-bit microcontrollers. And then you have the more popular ones that are now popular now, which are 32-bit microcontrollers. And you have a few, very few, but a few that are like 64-bit. But either way,
Mhm,
everything that you get is on that chip. So for me, a
okay.
microcontroller, like a 1 meg microcontroller, psh, that's
So here's a
1 meg, two
question.
meg. Oh, that's huge for me on a microcontroller.
Okay, so this is an F7 micro from, Wilderness Labs. It's a microcontroller that runs C sharp, and here's Wilderness Labs. Um, this has, like, Wi-Fi and Bluetooth. So when you said everything on one board, is that like I've heard the term system on a chip?
Ah, lovely. Yeah, SoCs. We call them SoCs. So systems on chips, because everything that you want or need to have, that's why it says even the peripheral. So the Wi-Fi, the Bluetooth, everything that is on that chip. In fact, what I could do is share with you some devices I have on my desk, and
Let's do it.
we can kind of work out which ones are microcontrollers, which ones are microprocessors. How about that?
Quiz time. Let's do it.
Okay. So,
Oh, okay, so you got a webcam pointing at your desk. Very
I do.
smart. Very
Yeah.
nice.
Okay. So, let's see. So, I'll pick up this one.
Okay.
Can you see it?
Yeah, it says Sony.
Yep.
It's really small. I can
Mhm.
see some pins at the bottom there, and I know that those pins let you plug in your LEDs or your wires or your peripherals and your stuff. Um, it doesn't have any kind of HDMI. I don't see anything there. I'm going to guess that is a microcontroller, but I don't know if it has Wi-Fi or Bluetooth.
Perfect. This is a microcontroller. Good guess. Okay. So let's go with this one.
Okay.
So this is, I'm going to turn it over so you can see. It has a
Oh, it has
LED,
a screen too.
has a
Okay,
huge
cool.
screen, see? And it has, sorry, LCD. It has for
Oh,
internet.
wow. Okay. I see some
You see,
USB there for a second.
yep. And then
Oh, an SD card, upper right corner. That looks like
it
a
does
slot for memory
it does have an extra slot for memory.
or storage,
So
rather. Pardon me.
question, is this a microcontroller or a microprocessor?
I want to say microprocessor, but then maybe it's a microcontroller with a bunch of stuff built in. But I'm going to guess microprocessor.
Okay, you were closer the second time. It is actually
Oh,
a microcontroller. Now, all
ah.
of this other stuff that you see
Mhm.
on here is on what we call a PCB. It's just a control board that we draw these metal lines and connect them with sensors and power. And then guess what? We can make this have all these sensors and all these actuators and things that do things. But all of the power on here is still on this chip.
And then you said PCB, that's a printed circuit board. That's
Correct.
kind of along for the ride. It's got all
It's
the
along
stuff.
for the ride.
Okay.
Exactly. So all of these circuits you see and all the little metal and little what looks like bumps and lumps and things there. These are circuits and capacitors and all these other great things that now I put together that surround that chip, that brain,
Okay.
to actually make this do more things.
Okay. So
So
then to level set for a second for our friends that are watching, that does not run Linux, that does not run Windows, that is not a personal computer, a PC.
correct. You're spot on. The two that you identified as microcontrollers, they would run RTOS. So you will hear things like, you know, Azure RTOS, because we have one, or free RTOS, or Zephyr. Those kind of things you might hear out there, those are RTOSes, and that's what these will run.
Okay, so those are little embedded real-time operating systems that aren't ones that, non-technical parents gonna have heard of. My dad's probably heard of
Right.
Linux, and he's probably heard of Windows. He probably hasn't heard of Zephyr.
Correct. Yeah, you kind of have to be in this space to hear it about that. Okay, so let's just try one more for the road. Here is this board. What do you think this one is?
Well, so you're gonna fool me again because I see on by your ring finger, I see a headphone jack, and then on
Mhm.
the lower right, I figure that's, internet, and then we got, we got, not USB, we got the Ethernet again.
Mhm.
I don't know anymore. I mean, that could be a PC of some kind. I'm gonna guess that's a microprocessor because it looks like it's got all the pieces I would need to be a computer.
You're right. This one is a microprocessor. It actually is one of the new hardware that is out there coming out. It's an open source hardware called RISC-V. Some people call it RISC-V because V, you get it? Anyway,
Oh, okay.
so very cool. And so I'm playing around with this one, but this one runs Linux, so embedded Linux. So you're right.
Ah, okay.
Yep.
So here's a question then. If I have a device that I like in my house, like I pass by my thermostat, and it's got a little touch screen on it, like you can imagine that this would be the guts inside the thermostat. And I
Yep.
got a touch screen, and it's got some Wi-Fi, and it does something to the furnace or whatnot. Do I want that to run Linux or Windows, or do I want that to run an RTOS or real-time operating system?
Great question. You really want that to run an RTOS. Let me tell you why. You want it to be really efficient. It really kind of does one major thing. It's going to control your thermostat. Now let's be clear. RTOSes and these microcontrollers are getting a lot more powerful than they were in yesteryears. We'll say that. But it's really kind of serving one purpose. It is a thermostat. It is going to turn up or down. It's going to tell you what the temperature is. And of course, microcontrollers do all of that, but you need it to really respond really quickly. You don't want it to use a lot of power and bandwidth because again, it's just a thermostat on your wall. So you don't want that to use a lot of power, right? You want it to just serve the purpose in which it's up on your wall for, to keep it hot or keep it cold. And so that would be a better purpose for a microcontroller, right? one singular purpose, for lack of a better term. It needs to be relatively low powered. It's constrained. Um, that's a perfect time for a microcontroller. Now, you
Okay.
know what? I just thought about it. Given you asked me that, do you know what a sensor, and I just keep throwing those words out, or actuator actually is?
I know what a sensor is. I don't know if I know what an actuator is. Before you tell me that, though, let me ask: if I took a Raspberry Pi and I made it light up an LED, you're saying that that would not be? It's a lot of power to light up an LED, but it's still okay as a learning tool.
Oh, absolutely. As a learning tool, absolutely. RTOS are a little bit different to program. You're gonna get into the C++ world, sometimes Rust. You're gonna have to really know a lot about computer architectures and registers. Little bit heavy if you're getting started. So
Mhm.
absolutely, go light
Okay,
up that
cool.
LED with your Raspberry Pi, and let's get some more IoTers out there. So absolutely.
Okay, so then, how would I then? I would have the thing, whether it be the Raspberry Pi or whatever, talk to my LED. But then you said I could include a sensor or an actuator. Tell me about what those are.
Okay, so let me see. I think I'll bring up another slide here to give you some examples of the things that are sensors and the things that are actuators. Just comment this. I don't know what it won't stay swapped. Okay.
All right.
All right. So you see my slide here?
Mm-hmm.
These are a bunch of different type of sensors. So you see there's the button keypad, there's temperature, motion, color, lots of things. And it's really easy to think about what a sensor is it's sensing your environment. So it's not doing anything, it's sensing something. I am sensing that there's smoke in the air. I am sensing that there is some sound. I'm sensing that there's motion. I am
Mm.
sensing what the moisture is in the soil, right?
So even knowing a location is sensing some external phenomenon, and it's a GPS, but a GPS is still a sensor.
Exactly, spot on, right? It is observing the world that we exist in. Your location is something that just exists no matter what. And so you are observing that I am sitting in Atlanta right now, and you are not sitting in Atlanta right now. So it's just observing our world and sensing it. So you're spot on. I know the light is on or
Okay.
the light is off. Yep.
Now, I remember when I hooked a battery up and I got my LED to light up, I was thinking about voltage. So I wanted to put 5 volts through one of the wires to make this light up. So there was some output where I was, pushing or sending 5 volts and it lit up. Are these sensors making voltage? Are they, is everything just come down to voltage when I'm saying like, it doesn't tell me like the soil moisture. I'm sure it tells me some voltage number.
Okay, that's a great question. So here's where, getting into some of the programming of it comes in. So if you think about how all of these work, you're absolutely right. They're based upon voltage, and either the voltage is high, so we sometimes like, it's turned high or turned low,
Mhm.
or it's we've gated the amount of power that goes high or low. You'll hear some of those terms. So these things are literally just, back to the ones and zeros. If this is turned high at a certain, I turn this sensor on high, for lack of a better term, that means power is coming to it.
Mhm.
And now it's taking that sensor, and it's the bits that are coming across then can be interpreted as what the soil moisture is. Or,
Okay.
the light is coming
Okay.
in. That means,
So,
there's power to it, it's turned high. And now
okay.
I can interpret those bits that's coming across based upon the voltage of what the light is.
Okay. So here's a question then.
Mhm.
Bit of an analogy. Remember our dumb Tony Stark thing here.
Yep.
I plugged it into USB to get power, but we know it's not smart. And the USB is giving it 5 volts at 1 amp.
Hmm.
So that's high because I'm pushing the button, and that's
Correct.
low. So if this were a sensor, it would be like sending information like a long high and then a low. It's like
Yes.
one
Yes.
zero one one one
Right,
zero one zero
exactly.
zero zero.
That's it. You're spot on, right? And it's just
Ah,
doing it so quickly, and based upon the pattern, then that can be interpreted as the soil moisture is at 5 versus the soil moisture is at 10, right? So,
okay. See, I've
spot
received some of these in the mail because I have this subscription from Adafruit.
Ah,
Adafruit
I
is
love
this one.
Adafruit.
Adafruit's the best. So Adafruit
Yeah.
has these boxes, and basically you get a subscription, and then you get like it's like the Columbia Records subscription for the old
Yeah.
people who are listening, and you
No
get
one is
like
no one's gonna know what that is. You know
no
that,
one's
right?
gonna
Okay.
know, just you
Yeah,
and
yeah.
I. So with Adafruit, like you subscribe to this, and Adafruit is it has got these subscriptions and stuff. And you get different things in the mail all the time, and then they come with what's the word? A data, like a little PDF that explains what each of these things does. It's
Hmm.
like a specification, right?
Yep.
So you have to read it and learn about, oh, the temperature thing is telling me the temperature this way.
Correct. Just spot on. Now,
Okay.
if we talk about actuators, though, that's a little different.
Hmm. Okay. So wait a second. So sensors are on the in, and these are on the out.
In a way, yeah. I'm going to put sensors are going to take data in and interpret it.
Okay.
Actuators are going to put data out. So I want something to happen. So this is a
Hmm.
easy way to think about this. Sensors sense the world around you. Actuators act on the world around you.
Oh, okay. I was trying to figure out what that meant. Action. It's
Action
actuator.
is action.
Got it.
Yeah. I mean, that's how I always remember it, right? Like, so actuators are going to act on your world. Sensors are going to sense your world. So, yeah.
Okay.
So,
Cool.
so let's think about this. So I have a motor driver. And this motor driver is going to take power in. It's going to have that power be modified it so that I can actually power or drive something, a motor. It's going to make the motor run. So it's acting as something that then drives the motor and gives me the motor to run to do things like I had a relay that I had a plant because me watering plant is it's just not good. And so this relay takes power and drives the pump that is then going to pump water in. So you see here, I used two actuators. One relay is to actually power the pump and think about it, turn things if you think about it that way, right? That's what motors do. I'm going to go round and round and then it sparks energy that does something, right? Um, and the LCD screens and the OLED screens, if you think about it, I am now putting power in and it's going to act on the data that I put in to display it to you. So these things that are you act upon these. I'm going to act upon the screen by sending data to it, and sending that data will then display on the screen to give me information. LEDs is going to take power in and it's going to act upon something and turn the light on or off, or depending on if you have an LED that has multiple colors, it's going to turn it to red or green. These things do actions. So that if you think about it that way, it's really
Okay.
it's going to act upon my world.
All right. So let me think about this. So I've got this little thing that came with Ada box number 18, and it's basically got a little screen. This was a e-ink display, like a Kindle,
Oh,
and
nice.
it's
Yeah.
got buttons at the bottom. So it says like Aquarius. I'm an Aquarius. So if I push the button, that's going to be a sensor because it's
Great
going to be giving
question.
information.
Okay, so look, buttons are sensors. It's sensing your touch, right?
Okay.
So that's a
Right.
sensor. It is sensing that your finger has touched something, right?
Hmm.
So think about it. You're acting, not the device, right? So when you push the button, it has a sense that pressure has been put down on it and
Hmm.
something is happening.
Okay.
So
So I
that's a
push it,
sensor,
and then the
right?
screen updates and gives me my Aquarius horoscope,
Right?
which is
So,
probably going to be. And then look,
oh, cool.
it actually crashed, which is kind of cool because I never put it on the Wi-Fi, so it's mad about something, and it says no. Actually, it says no such file, so that's kind of cool.
That is
So we
cool.
actually saw it crash in real time.
Look at you breaking things over there. But okay, so so think about it. The button sensed your pressure that you put down from your button that sensed it. And when that happened, it said, okay, I need to act upon that sensing of something and then go do something. Either show your horoscope or grab data from the Wi-Fi, go to some file, get information and bring it down. That's doing action. Your finger is doing the action in this case. So your finger is all the action. All the
Hmm.
button is doing is sensing the pressure you put down on the button.
Okay, so that means I could change this code and maybe it'll tell me my horoscope when it goes by, or
Exactly.
when the time changes, or whatever, or when the light changes and I turn the light on in the kitchen and whatever. Like I
Whatever.
decide.
You decide because again, it now has senses that a button was been pressed, and now you can have something coded. So say, let's act upon that.
Mhm. And you made a comment before how you don't have a green thumb and that you're not good at watering the plants.
No, not
So
good.
you could detect with the soil sensor on the previous slide
Mm-hmm.
that the soil is, there you go, soil moisture in the lower corner there. You
Mm-hmm.
say, hey, I detect that the voltage is whatever that tells me the soil moisture is low. And then I can go to the next page, which is actuator. I can tell the pump and the valve to work together to take maybe out of a glass or a bowl and then water my plants.
Actually, yeah, and I actually have done that before where I have exactly that. You just created one of my projects, little unbeknownst to you, where I have the soil moisture sensor in the soil. It says, okay, it's dry, and obviously she's not going to do anything about it. And I actually had a relay, and that relay turned the water pump on and pumped water from this like little small bowl I had that had water in it, and then put it into the plant. So, yeah, that's actually a real
That's
project I
cool.
had.
I did a thing once I told you about with a Raspberry Pi that was a little extra because I'm realizing now it was a mistake to use a Raspberry Pi, but I taped it to my garage door and then the garage door went up, up, up. And then you know how garage doors like turn like this?
Yeah.
And I detected with a sensor that the XYZ axis had turned. And then if
Nice.
it sits there for 5 minutes, it texts me. And I use Twilio, which is a service that you sign up for. It connects over the Wi-Fi and it says, hey, the garage is open because I kept driving away and leaving the garage door open.
Oh,
Sounds
smart.
like
Yeah, no, I love Studio. Yeah.
so it sounds like that's a good practice with the Raspberry Pi, but it's a little over the
It
top.
was a little overkill, just because you could have definitely done that with a microcontroller and a accelerometer.
Okay, and that
Yeah.
brings us to how folks can get involved and learn more about this kind of stuff. I am personally not affiliated with Adafruit other than I'm a fan. Their stuff is really, really cool. And they have a whole series of cool things you can check out. You can get lights and gift ideas, and you can go and here's an example. This is a what? Is this a micro? This is a microcontroller, right?
Mhm. Yep.
Okay. So this is one of their tools, and you can go in here and learn, and it'll tell you all the stuff that it has, and if it has Wi-Fi or not. And I really like their boxes. I think we both agree that the box is the great
Yeah.
deal.
I gotta find more time to play with my boxes. I
Yeah,
do.
they're
I get the
so
boxes
fun.
too. They
They're
are
so
fun.
fun.
And the
Cool.
Halloween ones are the best. So this is the perfect time to sign up if you're gonna do it.
I got the googly eyes one from last year that were two LED screens with
I
like
do
fish islands.
too. Yeah. Okay. I do too.
All
Geek
right, cool.
moments. Okay.
Well, this is a really good kind of a nice 30-minute explanation about the big basics of IoT. And if folks like it, please comment, and then we'll have Tara back. And Tara's also been on Azure Friday that you can check out at azurefriday.com because in your day job, you work on Azure IoT, the Internet of Things. And this is when you connect objects to the cloud, which is pretty cool as well.
Right. This is when I take all those little things that we just finished talking about and connect them to the cloud. So instead of just one little thing having communication just with, the sensors, you can have thousands of little things having connection across the world. Hey, I could even connect it and that maybe have your LED come turn on from here in Atlanta all the way there. So maybe
That's a
that's
good
the next
idea. We'll do
project
that
we'll
for the
do.
next project where you push a button and it turns on an LED. That would be a cloud hello world. Turns on an LED in my house.
Exactly. That'll be
All
perfect.
right, now we have another video. So please comment and subscribe. And thank you so much, Tara, for hanging out with me today.
Thank you for inviting me.